Hello viewers, welcome to CEC lectures. I am Dr. Preeti Jagwani from Department of Computer Science, Aribhat College, University of Delhi. So presently we are learning our series of operating system concepts, and within that we have started with the topic of virtual memory, and in the previous lectures we have seen that how swapping in and swapping out is happening in order to implement the technique of virtual memory. So now when a page is being swapped in and swapped out as and when required, it is a perfect possibility that a running program wants to access a memory page which is mapped into a virtual address space, but that page is somehow not loaded into the physical memory. Now that is very clear that virtual address space is kind of large as compared to physical memory. So for example, the virtual address space is having 120 pages and your physical memory is having only 60. So there will be 60 pages at least which are not loaded into the physical memory. And now what will happen when request for such a page arises, or a running program wants to access such a page which is mapped into virtual address space but not loaded into the physical memory. That means that page initially is kind of the process is not going to find that particular page, and this situation is known as page fault. And the situation of page fault we have already seen in our previous lectures in quite a detailed length. Now here what are we going to do in our today's lecture is how are we going to handle the page fault, what are the strategies to handle the page fault. So in case of a page fault we have three we can say ideas through which a system can go through. The first idea says the system can terminate the complete process. That means the process which is looking for a page which is giving a result in page fault, terminate that whole particular process. But what will happen in this situation, that user will become definitely aware of that these processes are running on a paged system, and paging should be, we can say, logically transparent to the user, which is we can say uh, if user will become aware that the systems are running on the page system, that's not a good idea. So terminating the user process is something which a system should not prefer. Then another idea is swapping out the whole process. That means freeing all its frame and reducing the level of multi-programming, so that in order to make sure that other other some processes are not going to generate the page fault. That means there were kind of, let's say, 10 processes which are going on, so the degree of the multi-programming was 10, and now it will be reduced to 9. So again that is also not a very appreciable idea. So the third idea, which says it's the most common, is replace some pages, and here comes the technique of page replacement. So the first idea was terminate the user process, the second was swapping out the user process instead of terminating, and the third one is replacing some particular pages. Now what is actually happening in case of a page fault and how we are going to tackle that? In order to understand that whole mechanism, let us see what is happening when a page fault is occurring. So when a page fault is occurring, that means one page has to be swapped in, which is already not available, and we don't have a space. So then in that situation a page from the physical memory will be moved out. So what is happening here? Whenever whenever the location of the desired page on the disk is to be found out, first of all we need to find a free frame. That means we need to find a free space where that particular page is going to be located. If we have a space free, I mean nothing like it, we can use it. But what will happen if there is no free frame? Then we need to swap out a particular page and swap in the required one in its place. So who is going to be the victim, or which page is going to be the victim of this page replacement algorithm? that has to be, you know, kind of chosen very carefully. And apart from this page replacement, not only the replacement but changing the page table as well as the frame table accordingly is a very important task. And after changing these tables, after, you know, we can say vacating the space by removing a victim page from physical memory into the virtual address space, the desired page will be read and, you know, copied into the newly freed frame, and pages and frame tables are freed accordingly. And then, you know, the user process will continue from where the page fault has occurred. So, this is what actually, you know, how are we going to handle this page fault as far as page replacement are considered. Now, coming to, you know, how to select the victim. So, the macro victim page which is going to be swapped out. So, there can be, you know, multiple strategies for that, but the macro level bifurcation says there can be two allocations here. One is global allocation and another one is local allocation, or on the contrary we can say there are two broad categories in order to classify the page replacement algorithms. One is the global replacement and another one is the local replacement. So, the global replacement says we are going to select a replacement frame from the set of all frames, even if the frame is currently allocated to some other process. So, let us say a particular process X has generated a page fault and now it is looking for some victim page to be swapped out. That victim page could be from any of the process, maybe process Y, maybe process A, maybe process Z. But the local replacement strategy says that each process select from only from its own set of allocated frames. So, let us say page X is generating a page fault. So, which particular page will be, you know, swapped out, that is going to be a page from the pages of the process X only, not from any other process. So, it can replace the pages from its own, or the process can replace the pages from any, you know, available process. So, if any available process's page is replaced, it is known as global replacement. And if we talk about local replacement, that means the replacement has to be selected from its own set of frames. So, for example, let us consider an allocation scheme where we have a high priority process to select frame from a low priority process for replacement, and here I am specifically talking about the global replacement technique. So, a process can select a replacement from among its own frame or the frames of any other lower priority process, and this approach allows a high priority process to increase its frame allocation at the cost of the low priority process. So, this is also a possibility that always choose a victim from a low priority process instead of selecting a victim from high priority process. But if the process is going with the local replacement strategy, then the important thing here is the number of frames allocated to a process are not going to change. For example, let us say we say that X is the process and it is going to, you know, swap out one of its page, and obviously it is going to swap in one of its page. So, the total number of frames in which pages are residing will be the same before swapping out as well as after swapping in. That means the number of frames allocated to a process does not change. While with the global replacement strategy, a process may happen to select only frames allocated to other processes, thus increasing the number of frames allocated to itself. So, here, you know, global replacement techniques can generate we can say disbalance between the number of frames allocated to the other process. So, for example, a high priority process is selecting a victim from a low priority process, then what will happen? every time low priority process page is being selected as a victim, that means the total number of frames allocated to that process is actually, we can say shrinking. So that's what is the difference between these two strategies. Another problem with a global replacement algorithm could be that a process cannot control its own page fault rate, but in local replacement algorithm its own fault rate can be somehow controlled by the process, because the set of pages in the memory for a process depends not only on the paging behavior of the process, but also on the paging behavior of the other processes. Therefore, the same process may perform quite differently because of the totally external circumstances. So, let us say we have a process A and it is being kept into some environment with a global replacement algorithm, and it is also kept on the another machine, it is also kept in some another environment. So, environment here could be have a difference of number of degree of multiprogramming could be different, and so on and so forth. So, the same process may perform quite differently because of the total external circumstances, because this whole paging behavior of the process depends on the other processes also, not only itself. Now, under local replacement, the set of pages in the memory for a process is affected by the paging behavior of that particular process. So, because we are talking about local replacement, that means however the paging behavior of that particular process is affecting, or how the way in which the paging behavior of that process A, let us say, is being changing, that is going to affect it. Otherwise, other processes, what in whatever way they are behaving, that is not going to change the status of the process A or process X. So, local replacement here might hinder a process, however, by not making available to it the other less used page of the memory. So, now another side of the coin could be that there is a process which are having some pages which are we can say less used pages, or that are not very frequently are in use. So, those pages can be easily swapped out, and the pages whose requirement is high can be swapped in. But in case of a local replacement, it is not possible. This is just possible in case of a global replacement. So, we can say that global replacement generally gives a greater system throughput, and therefore is more commonly used method. Local replacement, as it is completely we can say completely peripherized within one particular process, whether it is pros or whether it is cons. This is not kind of an something which is affecting others. But the global replacement strategy, because of being global, it is going to affect other processes also in both ways, in an advantageous way, in a disadvantageous way, both in a positive way or in a negative way, both. But still, because of having, or because of resulting in greater system throughput, this global replacement process is, we can say, more preferred. But the agenda here is, we need to select a particular page. Either we are going to select it from the process itself, from the frames of the process itself, or these are going to be selected from other processes which are currently inside the physical memory. But the point is, how are we going to select that page which is going to be the victim page? It could be of any of the process, of its own or from other, but which particular page, that is the we can say bone of contention, or that is something which we need to see very in detail. So, in order to find the victim for this page replacement, we have page replacement algorithms, or we have page replacement techniques. So, what are these page replacement techniques? I will be naming a few, and then we will discuss it in detail with the help of example. So in page replacement algorithms, we have optimal page replacement algorithm, we have first in first out FIFO page replacement algorithm, we have LRU page replacement algorithm, which is nothing but least recently used. Now let us see, let us try to explore all these page replacement algorithms one by one and see what are the advantages and disadvantages, pros and cons, as well as implementation mechanism. So we will begin with the simplest one, which is nothing but first in first out FIFO replacement algorithm. Here operating system is going to keep track of all the pages in the memory in a queue, because the moment we are talking about anything which is to be implemented in a FIFO manner, the data structure, the data structure which should strike in our mind is queue. So because that's a FIFO structure. So the operating system keeps track of all the pages in the memory in a queue. The oldest page is in the front of the queue, and when a page is needed to be replaced, the front page of the queue, or the page which is available at front of the queue, is selected for removal, we can say. So let us try to see this strategy with the help of an example. Here we have a page reference string. The page reference string says how the requirement of these pages is being generated. So the page reference string here is 1, 3, 0, 3, 5, 6 and 3. So initially we can say 1 is being asked, then 3 is being, then page number 3 is being asked, then page number 0, and so on and so forth. So initially we have, let's say we are talking about the demand paging technique, and initially we have physical memory as we can say vacant, we don't have any page here. So what is happening? So the columns or the stacks which you can say are shown in the lower side of the figure are going to give you the picture of the memory or the frames present, we can say. So initially no frame is present, and there is a request for page number 1. So it is going to be a miss as in page is not found in memory is a miss, and hit means page is found in the physical memory. So as physical memory is blank, it is going to give a result in a miss, and then 1 is being loaded, and here we have a free frame also, so that's not a problem. Then we have the request for 3. 3 is also resulting in a miss because presently only 1 is there. So 3 is being loaded here after a miss. Then we talk about 0. 0 is also being loaded here after a miss. Now again the request for 3 is coming up. Now 3 is resulting in a hit because it is already available in the memory. So 3 is a hit. Now it comes as now the next request comes for the page number 5. Now here it is going to be a miss again because there is only a space of 3 pages, or we can say there are only 3 frames here. So we need to create a space here for the page number 5. Now in order to create the space, the page number which was entered first, and that was page number 1, is going to be replaced, and here it comes as the FIFO strategy, and now the page number 5 is being loaded. After page number 5, the request comes for page number 6. Now what is happening? 5 is there, 3 is there, and 0 is there, but 6 is not there. So again it's going to result in a miss, and then we will be taking out 3 because now that is on the we can say front of the queue. We will be taking out 3, and we will be looking for we will be replacing it with 6. Now again let's say there is a request for page number 3. Now what is happening? Again 3 is not here because we just removed page number 3. So we will be removing 0 because that is now at the front of the queue, and we will be loading 3. So in this whole kind of page reference string for 7 pages, there are totally 6 page faults, and the only one in which 3 is being kind of looked for at the fourth step, that is going to give us a hit. Otherwise all other searching occurrences for a particular page are going to result in a miss as far as this particular example is concerned. So we have a total page faults of 6 in this example. Now this was first in first out. So the page number 1 was taken in first, and so it is taken out first, then 3 was taken in, and then 3 was taken out, and so on and so forth. So this is maintained here as a queue. Now what are, we can say, kind of pages, what is the pros and cons of this particular algorithm. So this is one of we can say the simplest algorithm to be implemented, but the disadvantage here is it is not going to give us the optimal results, because while looking for a page reference string of 7 of length 7, if it is resulting in a page fault of 6, it is obviously not a we can say not an a good optimal performance. So that's the problem with this, but the strategy is the simplest one to implement. Another one problem which is there with first in first out and some other page replacement techniques is Baladi's anomaly. Baladi's anomaly says that it is perfectly possible to have more page faults when increasing the number of page frames if we are using this first in first out page replacement algorithm, and that is very clear in this example, as in we were having no page initially, then we had 1 page, then we had 2, then we had 3. But it is not going, increasing the number of page frames, it is not going to help us in decreasing the page faults, because the Baladi anomaly is occurring here and more page faults are being occurred along with the increasing of page frames, and this is also we can say one of the disadvantages of first in first out page replacement algorithm. So in order to prove this Baladi's anomaly, we consider a reference string of, let us say 321, 032, 432 and 104 and 3 as given on the screen. So here are the page reference string is 321, 032, 432, 104 and 3 slots. So if you want to implement one we can say first in first out algorithm here, you are going to get total 9 page faults. But even if we increase the slots to 4, from 3 to 4, we are increasing the slots. So what is happening here? If we are increasing the slots, that means there will be more pages in the memory. Then in that situation, we are going to get 10 page faults. So with 3 slots, we are going to have 9 page faults with this reference string, and if we are going to increase our slots to 4, we are having 10 page faults. So what is actually happening? It is happening that more page faults are being occurred when increasing the number of page frames in case of first in first out. So that's one of the we can say disadvantages of this first in first out replacement strategy, that Baladi's anomaly can very well occur here. So here in this lecture, what we have seen is we have started with what actually page fault is and what will be the we can say strategies to handle this page fault, and we have seen page replacement algorithm as how and when they are required, and we have seen one page replacement technique in detail, and that is first in first out, that we have seen with the help of an example. Hope you have enjoyed the lecture, and here is a list of, here is the reference which is being used for the preparation of lecture. Other page replacement techniques we will be taking in our upcoming lecture. Till then, please take care. Goodbye.